Okay, homework 10.3, question number 1 and number 2. Those two questions are quite similar, and for those questions, they are given the regression line, and also you know the mean of your x and the mean of your y. They are asking what is like the best predicted y value. Okay, so for those questions, the strategy is, if you go back to the slides, page number 7, you read number 2 and number 4, and you will know that use the regression equation only if the linear correlation coefficient, little r, indicates that there is a linear correlation between the two variables. So first, you have to make sure the two variables are linearly correlated based on the value of little r. If they are linearly correlated, then you can use the regression line for prediction. Otherwise, you go to number 4. Otherwise, the best predicted value is the sample mean. So that is y bar. Okay? So let's go to the first step. That is to check whether your x and y are linearly correlated. So you are going to check the table and draw some plot like this. So if you check the table, get the critical value, and you know that from the -1 to the critical value, and from the positive critical value to 1, those two are like the critical region, which means your little r, if fall into those two regions, your x and y are linearly correlated. Otherwise, your x and y are not linearly correlated. Okay, so this is like the strategy. So for the first question, you know your little r is 0.916. And you want to check the table. So here the sample size is 20. Alpha is equal to 0.05. So if you go to 20, alpha equal to 0.05, you can see the critical value is 0.444. Okay, so you can draw a very similar plot as the previously I show you. So here you will write negative 0.444, and here the critical value will be 0.444. Sorry that I cannot draw this plot directly on my computer. So I have to show you using this plot I already have. And your little r, where is your little r? Your little r is 0.916. So it should be somewhere here in the critical region. Okay? And because your little r is in a critical region, you know that your x and y are linearly correlated, which means you can use this regression line for your prediction. Okay, then in order to predict y, you know your x is 92. So you plug in x equal to 92 into this formula. Okay, so your answer should be negative 16.32 plus 1.13 times 92. Okay, and you, of course, you should round to 2 decimal places. So that's this one. For this second one, it is very similar. You have the correlation coefficient equal to 0.225, and you want to check the table for the critical value. This time you have sample size of 80 and alpha equal to 0.05. So go back to 80 and 0.05, that's the first column. So it's this value, that's the critical value, 0.22. Okay? And you want to compare your 0.22 and your 0.225. Or you can go to the plot again. So this value here will be negative 0.22, and here will be positive 0.22. And your 0.225 again is in the critical region here. So that means you can use the regression line for your prediction. Okay? So find the best predicted pulse rate of the woman who is 75 tall. So you plug in x equal to 75 into this one. Okay? Let me show you how to do that in StatCrunch. Quickly show you. So the previous one will be very similar. So if you go to data, compute, expression, you plug in this expression here. Let's see. Oh no. Okay, I cannot copy, so I will just manually plug in that. Data compute expression 17.6 plus 0.92 times 75. Okay, so if you click compute here, you will get this number. Okay, so that should be your answer.